Welcome to the second problem of Unit 3. If you thought that the health situation had started to look grim in the last problem when we dealt with waning immunity, this time circumstances have become even more dire. There's no immunity at all. Instead of the typical SIR model, people simply switch back and forth between susceptible and infected. We're assuming that no people are lost in this scenario. So that means that the total number of people, which I'm going to call N, stays constant. Since every person is either in the S group or the I group, we know that at any given moment, S plus I equals N. Here, once again, are the standard SIR model equations. You'll need to change these to reflect the new situation, similar to what you had to do in the last problem. Start by reducing this system of differential equations to a single equation that contains only I and N, but not S. Then solve this equation numerically using the trapezoidal method, which, in case you forgot, I will show you right now. Remember that the trapezoidal rule finds the value of a quantity after an additional time step by taking the original quantity and adding to it h times the average of its rate of change at the 2 points in consideration. Now I've used notation here that probably makes sense, but just to be clear, x sub n is just equal to x measured at the nth time step, and x dot n is just equal to the time derivative of x at the nth time step. Now once you go through using the trapezoidal method, I want you to solve for S and then convert your equations for I and S into Python. Right now, this applied code contains expressions for S and I that come from the forward Euler method. Before you fill in the program with the trapezoidal rule, run it as it is right now. Try it first with h set to 10, as it is here, and see what happens. Then change h to equal 0.5, run the program, and compare the difference between the plots. When you've changed the code as we've asked you to, see how each of these step sizes works with the trapezoidal method instead. After you're done with everything, set h to 10 and press submit.